Hello friends, myself Praveen Kajri. Welcome to the video classes. In this class, I am going to discuss the first chapter of PUC first year, that is some basic concepts of chemistry. So every discussions in chemistry starts with the definition of matter, right? So we also start our discussion with a statement of matter. So what is matter? So matter is anything which is having certain mass and which occupies a certain space. So those two criteria it has to fulfill. So let me write that. So anything which is having mass and which occupies certain space. If you want to say anything as a matter, then these two criteria has to be fulfilled, right? So let us take a liquid water. Let us take a liquid water. So what is this? This is nothing but a liquid water. Right, whether liquid water is a matter or not. So if you are asking that question, that means you have to check whether this liquid water is fulfilling these two criteria or not. So liquid water, so whether it is having a mass, yes, of course. So that water, if you take certain amount of water, then that has a certain weight. So therefore liquid water is having certain mass. First criteria is fulfilled. So what about this? Whether it occupies certain space? Yes, of course. So liquid water is occupying available space for it. Right. Therefore, liquid water is a matter. Right. So what I am going to do is, I am going to cool this water to ice. So it becomes ice. Right. So after cooling, liquid water is matter. What about ice? Whether ice is a matter or not. So let us check whether it fulfills these criteria or not. So ice is also having certain amount of ice. If you take certain amount of ice, that has a certain mass. Of course it has certain mass. So what about this ice is fulfilling this criteria or not? Second criteria, that is whether it is occupying certain space or not. Of course, the ice is also occupying certain space that is available for it. So therefore, ice is also a matter. This is also a matter. What if I heat this liquid water? So if you heat liquid water, it will get converted into a gas that is known as water vapors. That is known as vapors. So if you heat the liquid water, it will get converted into water vapors. Let us check now whether this water vapors, this gas, whether it is a matter or not. So if you want to check whether it is a matter or not, what we have to do? We have to check whether it is fulfilling these two criteria or not. So whether this gas, water vapors, is having mass or not? Yes, of course it is having mass. How to check that? So you have to fill that water vapors into the balloon and you have to wait. So before filling that water vapors into the balloon, so balloon has a certain weight. After filling the water vapors into the balloon, the weight of that empty balloon is increased. So what it indicates? It indicates that this water vapors, gas, is also having certain mass. Right. First criteria is fulfilled by this vapors. Right. So then check for the second criteria, whether it is fulfilling the second criteria or not, which has to occupy certain space. Right. So these water vapors are occupying the space available in the jar in this apparatus. Right. So therefore it is also occupying the space and it is having certain mass. Therefore water vapors is also a matter, right? So therefore water is a matter, right? Water is a matter. It exists in three states. So that is a liquid state, ice is the solid state of water, and vapors are the gaseous state of the water. So next what statement I can write is, there are three states of matter, right? So one is solid state, second one is liquid state, third one is gaseous state. Right. So here what we have discussed is matter. Matter is anything which is having mass and which occupies certain space. By taking an example of water, liquid water is a matter because it is having a mass, because it is having a weight, and which occupies certain space, which occupies the available space in the jar. Therefore liquid water is a matter. What about ice? Ice is also having certain mass, it weighs, right? We can find the weight of the ice cube, and then also it occupies a certain space. Therefore ice is also a matter. And vapors are also vapors of water. That means it is having certain mass, we can weigh that vapors, and then which is occupying certain space, which occupies the space available for it. Therefore water vapors are also a matter. In all these three states, molecule present is H2O, it is not changing. H2O molecule is not changing, only the state of this matter is changing. Therefore what we can say is, every matter exists in three states. First one is known as the solid state, liquid state, and gaseous state. Solid state, liquid state, and gaseous state. Ice is the solid state of water, liquid water is the liquid state of water, and vapors are the gaseous state of the water. And it is not only true for water, it is true for every matter, right? Let us take iron piece, right? So let us take iron piece. So that iron piece is in solid state at room temperature, right? If you heat that iron piece to the high temperature, so that will get converted into liquid state, right? So if you heat that liquid iron to the higher temperature, then that will get converted into gaseous state. Therefore that iron piece is also exist in three states. So it is true for all the matters that exist in nature. Every matter exists in three states, that is solid state, liquid state, and gaseous state. Let us take an example of oxygen gas. So that oxygen is exist in the gaseous state at room temperature, right? So that gas, we know that gases also have mass, we can weigh it, and it occupies certain space. So oxygen cylinder, in that oxygen is occupying certain space. Therefore what we can say is, oxygen exists in gaseous state at room temperature. If you cool that oxygen to the lower temperature, so what happens? The gas molecules, oxygen molecules are condensed to form a liquid state. So that liquid state also oxygen molecules are there, right? So if you cool to the higher, very low temperature, then that oxygen can be converted into solid state. So that oxygen is also a matter that exists in three states. Here my intention is to say that every matter that exists in the nature are possessing, are present in three states. that is one solid state, another one is liquid state, another one is gaseous state. These are the three states of matters. So now let us move on to the properties of solids, liquid and gaseous state. Right. So next thing what we have to discuss is properties. Solid, liquid and gaseous states. Gaseous states of matter. So let us make a column here: solid state, liquid state, gaseous, gas. So these are the three states. So let us take an example of water itself. Water exists in three states. One is solid state, ice, liquid state, liquid water, and gaseous state, water vapors. Right. What about the mass of solid state? It is possessing definite mass. Let us take this is an ice cube. Let us assume that this is an ice cube. Right. So this ice cube is having definite mass. Right. So let us assume that this is having approximately 5 grams. So that is the mass of this ice cube. Right. So that means that is the definite mass for the solid state. Therefore, first point what I can say is solids have definite mass. What about liquid state? So what about liquid state? So let us take a same amount. This is 5 grams of ice cube. Let us heat it. It will get converted into liquid state. Right. So what is the mass of that liquid state? Again, it has to weigh 5 grams because we have not changed anything. We have not taken outside anything from that ice cube. Right. That has to weigh 5 grams itself. Therefore, liquid state must also possess a definite mass. So it is also possessing definite mass. So what about the gaseous state? Again, let us heat that 5. So what we did is we took 5 grams of ice cube and we heated it. So again 5 grams of water we get. If you heat that water to the higher temperature, more than 100 degrees Celsius, then what happens? All the water molecules that are present in the liquid state are get converted into gaseous state. Right. So in that case, so if you collect all the gas molecules that are present in that vapor, so if you weigh that, so that must also possess definite mass. That means 5 gram only. Therefore, so liquid gaseous state also has a definite mass. So first very important property what we have discussed is solid states of any matter is having a definite mass. So liquid state of the same matter is also having a definite mass. Gaseous state of that matter must also have a definite mass. Right. So let us move on to the second property, that is called a volume. So first we have to understand the meaning of volume. Roughly let us understand that term as the space occupied by that substance, that matter. Right. Space occupied by that substance is nothing but the volume of that substance. So for the time being, understand like this. Right. So what about the solid state? So again let us take the same 5 grams of ice cube, that is the solid state of water. So what is the space occupied? It is occupying a definite space, right? It is occupying a definite space. So that means solids have definite volume. Right. Next point what I can write is they possess definite volume. It is occupying a fixed volume. The volume is not changing. Right. The space occupied by that matter is fixed. That is in solid state. Right. What about the liquid state? So whether it is having a definite volume or not. So let us take 100 ml of water. Yes. So that 100 ml of water, if you take in a different apparatus, so let us take in this container. So that the space occupied by that amount of water is again 100 ml. If you take it in a long tube, so if you pour that water, that volume of water here, so again it is 100 ml. If you take it in a conical flask, right, so what is the volume of that water? If you take 100 ml, again it is 100 ml. So that means even if you take that same quantity of liquid in different containers, its volume will not change, right? So here also it is 100 ml, here is also it is 100 ml. 100 ml is the volume occupied by that water, right? So liquid state of any matter is also having definite volume. So this is liquid water is also having definite volume. So solid state is also having a definite volume, liquid state is also having a definite volume, right? You understood what you mean by definite volume for liquid state, right? So what about gaseous state? What about gaseous state, whether it is having a definite volume or not? So volume means, what we understood is, it is the space occupied by that substance or that matter. Let us take 100 ml of oxygen gas in a small balloon, right? So if you open that balloon, what happens? So all that gas that is present in that balloon is going to spread throughout the room, right? What you mean by the spreading of that oxygen gas throughout the room? So it means it is occupying all the volume, all the space that is present in the room. Therefore, this gaseous state of any matter does not have any fixed volume, right? It does not have any fixed volume. So if you place it in a small, if you keep it in a small space, that gas will occupy that space. So if you allow it to expand to the larger volume, larger space, then it occupies whole space. So that means it does not have any fixed volume, or it does not occupies a fixed space, right? So therefore the points to be remembered here is, gaseous state does not have fixed volume. So this is the second point we have to remember. So let us move on to the third property. So third property is shape, right? So what is the shape for solid state? So let us again take the same example, ice cube. In ice cube, water molecules are held at a fixed position, right? And therefore they are not moving from one place to another place. So because of that, the solid state of the matter possesses a fixed shape, a definite shape, right? The shape of that solid state will not change with the time. For example, let us take this chalk piece. Here, the particles that are present in this chalk piece are held at a fixed position. They are not moving from one place to another place. Therefore, it is possessing a definite shape, right? So therefore, what I can write here is, in solid states possesses definite shape. So what about liquid state? Let us take 100 ml of liquid water. So that 100 ml of liquid water I am going to take in a long tube like this, long tube, right? So this is occupying 100 ml liquid water. So what is the shape occupied by that liquid water? That is nothing but the shape of this container, long tube. So it is occupying the shape of that container. So if I take a conical flask, if I add 100 ml of water, so what happens? That 100 ml of water is taking the shape of this container, conical flask. So if I take in a round bottom flask 100 ml, again that 100 ml of water is taking the shape of this container. So therefore it does not possess any fixed shape, The liquid state is not possessing any fixed shape. Right. So therefore, liquid state of any matter does not have a fixed shape. Therefore, what I can write here is liquid state does not have a fixed or a definite shape. In other words, what I can say is liquid state of any matter is taking the shape of the container in which we are adding. Right. Therefore, liquid state does not have any definite shape. So what about gaseous state? So let us take a gas. So let us fill that gas in a long balloon. What happens? So that gas is occupying the space available in that long tube. That means it is nothing but it is occupying the shape of that tube, shape of that balloon. Right. If I take the same gas in another a different shape, heart shaped balloon, again that gas is occupying that heart shaped balloon. Right. So that means gases also does not possessing any definite shape. Right. So that I am going to write here. They also does not possess, does not have fixed or definite shape. Right. So these are the three important points we have to remember. First one is solids have definite mass, liquids have definite mass, gases have definite mass. What about volume? Solids have definite volume, liquids have definite volume, but gases does not have any definite volume. So third point is solids have definite shape, liquids have does not have any definite shape, gases also does not have any definite shape. These are the important points. Now, in order to understand next property, we have to understand a very basic structure of these solid, liquid and gaseous states. Let us again take the example of water itself. So in the solid state of water, that is ice, right? So in ice, the water molecules, H2O molecules, are held very close to each other, like this. H2O molecules are held very close to each other. Right. So the particles or the molecules are held very close to each other. Right, in solid state. So in liquid state, the particles are somewhat away from each other. Right, in liquid state, the particles are loosely held with each other, or the molecules are held loosely with each other. Right. So in gaseous state, the particles are far away from each other, like this. Particles are away from each other. They are not held very strongly with each other. So in liquid state, in solid state, the particles are held very strongly with each other. Right. In liquid state, the particles are loosely held. In gaseous state, the particles are away from each other. They are not held very strongly with each other. So what is the force that holds these molecules? That is known as intermolecular force. Right. It's intermolecular, not intramolecular. Intra means within. Inter means in between two different things. International, like that. So in solid state of water, that is in ice, the water molecules are held very strongly with each other. So the force that holds the molecules with each other is known as intermolecular force of attraction. So what is that? Intermolecular force of attraction. So that intermolecular force of attraction is strong in case of solid states. strong force of attraction is holding the water molecules with each other, right? That is in case of solid states. In liquid states, this intermolecular force of attraction is less than that of the solid states. So the force that holds the molecules in liquid state is less compared to the solid states. Therefore they are loosely held with each other. These molecules are held loosely with each other, right? So in case of gaseous state, this intermolecular force of attraction is very negligible, very small or negligible, right? So what it indicates, because of that negligible or very small intermolecular force of attraction, the gas molecules are away from each other, okay? They are far from each other. The intermolecular force is very less. The binding force, the force that holds the molecules with each other is very less in case of gaseous state. Therefore in gases the molecules or the particles are moving away from each other, right? So in solid state the intermolecular force of attraction is very high. In gaseous state the intermolecular force of attraction is very small or negligible. In case of liquid state, the intermolecular force of attraction is in between that of solid state and gaseous state, right? So this is one point. I am going to write it afterwards. So second point is, because of the strong intermolecular force of attraction in solid states, the particles are held very closely with each other. So because of that strong intermolecular force of attraction, there is no space between two particles in solid state. So now because of that intermolecular force, the distance between the two particles is negligible or very small, right? Intermolecular distance. So distance between the particles is very small or negligible, right? What about the gaseous state? In gaseous state, intermolecular force of attraction is negligible. That means there is no intermolecular force of attraction, there is no binding force between the particles. Then the particles are moving very freely away from each other. Because of that, the distance between the two particles, interparticles or intermolecular distance, is very high. Intermolecular distance in gaseous state is very high. Intermolecular distance or interparticular distance in solid state is very small or negligible. In liquid state, the interparticular distance or intermolecular distance is in between to that of solid states and gaseous states, right? These 2 points we have to remember. So one is intermolecular force of attraction, another one is intermolecular distance, right? That I am going to write here. So that is fourth property is a strong intermolecular force of attraction. So in solid states, intermolecular force of attraction is very high. Strong intermolecular force of attraction exists in solid states of the matter. So in gaseous state, a very small or negligible intermolecular force of attraction, right? So in liquid state, the intermolecular force of attraction is in between to that of solid state and liquid state. So intermolecular force of attraction is in between to that of solids and liquids, solids and gases. Right, so this is the fourth property what we understood. So fifth property is intermolecular distance. So very small or negligible intermolecular distance. So here intermolecular distance in gaseous state is very high. Intermolecular distance. So in this case, intermolecular distance in liquid state, intermolecular distance is in between to that of solids and gases. Right, so these are the two more properties of solids, liquids and gaseous states of the matter. Right, so there are 5 properties: mass, volume, shape, intermolecular force of attraction and intermolecular distance. This intermolecular force of attraction is also known as interparticular force of attraction. So in general I have to use the particle as a term here instead of molecules. Right, so here also intermolecular distance, interparticular distance, particles, the distance between the two particles in the same state of matter. Right, now one more point what we have to understand is how to convert solids into liquids, liquids into gases. We know from our experience that solid can be converted into liquid by heating. So liquid can be converted into gases again by heating. Alright, so gases can be converted into liquids by cooling. Liquids can be converted into solids again by cooling. Right, so let us understand it in detail. So let us take solids. So how to convert that into liquid states? By heating. Right, so by heating we can convert solids into liquid state. So best example is take ice cube, just heat it, it will get converted into liquid state. So if I heat a liquid, what happens to the higher temperatures? Again heating. So what happens? It will get converted into gas. Right, so if you cool this, if you cool the gas, it will get converted into liquid state. Again if you cool this, you will get a solid state. What actually we mean by heating? Let us take a solid state. Right, so in solid state the molecules or the particles are held very closely with each other. Right, so these are the particles which are held very closely with each other in solid states. So if you heat this, so heat is a form of energy. So heating means what? You are supplying heat into this matter. So this energy, heat energy, is absorbed by the particles that are present in this matter, in this solid. That heat energy what you have supplied is absorbed by these particles that are present in this matter. So these particles, after getting energy, they will enter into the excited state. So these molecules are in excited state. So what they does? They starts vibrating about their mean position. So because that vibration, after getting the heat energy, the particle starts vibrating about their mean position. That is known as thermal agitation. Because of that thermal agitation, intermolecular force of attraction is going to break. Okay, the force of attraction that holds the particles is going to break because of that thermal agitation. right? So intermolecular force of attraction is breaking. That means the particles are moving away from each other, right? Because of that movement, that solid state of the matter is get converted into liquid state, right? So what happens? You are supplying heat. Heat is a form of energy. Because of that, the particles that are present in the solid state are absorbing the heat energy. So because of that absorption, the particles are in thermal agitation. Okay, what is that? Thermal agitation. Thermal agitation. Because of that thermal agitation, intermolecular force of attraction is going to break. Because of that breaking of intermolecular force of attraction, the particles are moving away from each other. So because of that, the solid state is get converted into liquid state, right? So now the particles are loosely held. The particles are loosely held like this. So now again you are going to heat it. Again you are supplying the heat energy. Again the particles that are present in the liquid state are absorbing the heat energy. So that again this particle is under thermal agitation. So again that is in excited state, that is going to vibrate about its mean position because of that the higher energy. So that particle is going to break all the bonds, all the intermolecular force that are present around it. Because of that will enter into the gaseous state. That particle is free from all the forces that are surrounding that particle, right? So therefore the particles are moving away from each other, breaking all the intermolecular forces. So that will enter into the gaseous state, right? So this is what happens because of heating, right? Solid state can be converted into liquid state. Why that happens? That is because of this heat energy, right? So heating. Next, liquid state can be converted into gaseous state by heating, again by supplying the heat energy, we can say, right? So reverse, let us understand in the reverse way. Let us take the gas. So now let us cool it. So what do you mean by cooling? It just means that you are just removing the heat energy from that substance, from that gas. You are removing the heat energy, you are removing heat. That means the particles that are present already in excited state, they are coming to the ground state, they are coming to the lower energy state because they are losing the heat energy. So because of the losing of heat energy, the particles are started to settle at a particular position. So therefore, because of that, intermolecular distance is reduced and then intermolecular force of attraction is increased. So therefore, that will enter into the liquid state. Now again cool that liquid state of the matter. What happens? Cooling means again removing the heat energy. Again the molecules that are present still in a higher energy are coming back to the lower energy state. They are losing all the energy that is present in the form of heat. So because of that, the particles are starting to settle at a fixed position. So because of that losing of thermal energy, the intermolecular distance is reduced. There is no thermal energy to break the intermolecular force. Because of that, the intermolecular force of attraction is increased. So therefore, the substance or the matter in the liquid state is get converted into solid state. In solid state, the intermolecular force of attraction is very high and the intermolecular distance is very less or negligible, right? So this is because of the cooling of liquid state. So I hope it is clear now. So one more condition is there. So this is all about the variation of temperature or variation of heat that will change the states of the matter. So one more condition is we can also change the pressure. So that will change the states of the matter. So for example, you have heard the name liquefied petroleum gas, LPG. Expanded form is liquefied petroleum gas, liquefied. How they have liquefied that gas? By applying higher pressure. That gas is compressed within a cylinder by using high pressure. Because of high pressure, right? So these all gas molecules are coming very close to each other, right? So because of that, the intermolecular distance is reduced. So because of the reduction in the intermolecular distance, intermolecular force of attraction came to exist. So because of that, the gases are get converted into liquid state. Therefore the name liquefied petroleum gas, actually it is a petroleum gas, we have liquefied it by applying higher pressure. So why it is get converted into liquid state? Because of the application of high pressure, right? So again, liquid can also be converted into solid states by increasing the pressure at a particular, of course it happens at a particular temperature, that will come to know in the upcoming classes. So for the time being, there are two very important conditions. By varying them, we can change the state of the matter. So one important condition is temperature or the heat. So another one is pressure. By changing temperature and pressure, we can change the state of the matter. This is what the point I have to make here. In this class, we understood the definition of matter, and there are three states of matter: solid state, liquid state and gaseous state. And then properties of the solids, liquid and gases are discussed. So those properties, there are 5 properties. One is about mass, second one is volume, third one is shape, fourth one is intermolecular force of attraction, fifth one is intermolecular distance. So these are the 5 properties we have discussed. And then what are the conditions? By changing them, we can change the states of the matter, that is nothing but temperature and pressure. By changing the temperature and pressure, we can change the states of the matter, right? So in the next class, we will discuss other aspects of this chapter. Please like and subscribe my channel for more updates. Thank you so much.